Yeah. So so today's agenda is basically we'll first understand each other's background, and then I'll walk you through the course content in details. So what are the contents we'll be discussing? What are the contents we'll be discussing during this 60 hours of program, and also we'll if time permits, we'll discuss about the type of projects we execute using big data technologies. So these are the stuffs for today's agenda. Okay, and from the next session, like tomorrow onwards, we'll start directly jumping into the programming part. We will start doing hands-on. Okay, because most of the theory things we will be discussing while working through the hands-on or the programs only. There are roughly 150 programs are there. We will all be doing hands-on. So without further delay, let's start. So myself, Siddharth. So I'm having 10 years of experience into software engineering as well as data engineering. So I'm pretty much like into big data like Hadoop, Spark, and all. I started almost like 7 years back. So I'm currently also associated with a organization. It's a it's a fintech company, financial technologies, and I'm working here as a big data technical architect. And along with that, I do provide these trainings also as out of my own passion. So I started this training stuffs almost like 2.5 years back. And like every month, almost like 8 to 10 people, I'm taking a batch. I'm starting a new batch with. And if you're following me on WhatsApp, you might be observing every month almost 4 or 5 people are clearing interviews. Okay, yesterday only 3 people informed me they got offer. One means all are Indian people only. Here, like yeah, US people also joins but there, like it's very easy to crack interviews and all. But here in India, I'm saying like almost every month you will see 4 or 5 people are clearing interview, and and I'm working mostly always on startups. So I've executed more than 10-15 projects in the past, end to end, starting from the scratch till deployment or production, doing the solutions and designing and means optimizing the pipeline and all this. So I have a good experience on all these stacks. So that's quick introduction about myself. So let's start with yours. I'll not take more time. We'll quickly understand each other's background and then we'll directly start. Okay. So Rohit, you want to go first?
Hi guys, my name is Rohit. I worked in Android Java for 3 years. Now I want to move to the big data and Hadoop. I selected in H1B in 2020, but the process is still going on, and I just want to change to Hadoop big data. That's my thing. Thank you.
Okay, so your background from Android, that means you're using Java programming and all this. And how many years of experience you mentioned?
3 years.
3 years, okay. 3 years, Android, and you are here in India or US?
I'm in India.
Okay, but you have your H1B or how it is?
Yeah, that's still in process.
Oh, okay. So, okay, 3 years of experience. Android, do you have any SQL background also? SQL?
Yeah, we do have SQL, PHP, JavaScript.
Okay, SQL, PHP, and JavaScript. Okay. Okay, fair enough. And what's your expectation from this program?
My expectations, I just want to join in the big data.
Okay.
I mean, I want to crack the big data thing.
Okay, so basically migrating from current technologies to big data. Okay.
Yep.
To be fair enough. Yeah. So. Okay, fair enough. So yeah, Ashutosh, I think you just joined now. So what we discussed is basically today's agenda is basically we'll first understand the course content and the type of projects we'll be executing using big data. So from tomorrow onwards, we'll start doing the hands-on as we have discussed earlier. From the day one only, it's all programming. Okay, through programming only, we'll be learning the theory part as well. Okay, so right now I'm just walking you through all like I'm just introducing each other in this batch to understand each other's background. That also helps a lot because sometimes like here we are learning AWS, maybe tomorrow you are getting a project where GCP has been used, so we can get to know each other. If we know each other's background, then you can get help from each other also. That's the whole agenda.
Great, that's great.
Yeah. Okay. So yeah, Abhishek, you want to go next?
Yeah, so my name is Abhishek. So I'm basically a DevOps engineer working in Cerebron.ai. It's a US-based startup. So we basically work with microservices development using Java, Helm charts, Kubernetes. So we basically deal with Kubernetes. So recently we have started shifting our focus to MLOps and data engineering, like dealing with data sets and all. So that's why the interest is more towards big data because it's the new hype in the industry. So I would just want to move my career to data science and big data and analyze data, play with more data. That's what my aim is.
Okay. Okay. So how many years of experience you have now?
Just 1 year, not much, just 1 year.
Okay. So 1 year experience, and you are you have mentioned all like DevOps using Kubernetes and all this, and
Yeah,
service
yeah,
admin and all this.
yeah.
Okay. Okay. Fair enough. So any cloud experience you have?
Yeah, AWS, I have experience in AWS. Basically, we deal with AWS only. And in microservices, I have basically used Java with Spring Boot.
Okay. Microservice using Spring Boot
Yeah,
and
Spring Boot and Java. Java was my programming language.
okay. Kubernetes, you are using AWS EKS.
Yeah,
How
yeah,
was
we have used EKS also on premise, also custom also. So I worked with K3s on Edge. I worked with EKS recently, and I've also used kubeadm kops to deploy the Kubernetes cluster in AWS as well as in on premise.
okay. Created any dashboards to monitor the services or pods therein?
Yeah, sure. We have worked with pods, config maps, CRDs, pod sets, and all.
Okay, okay, fair enough. And you want to move to DS, that's why you want to spend some time understanding the data
Big
engineering.
data. Yeah, because I want to work with more data. Like it's okay, but we have to move to data because if we are moving to cloud, then ultimately it's the data that is moving to cloud. So we need to understand data more.
Exactly, exactly. So in order to move to data science, the first thing is basically we need to understand the data engineering part, because that's the
Yeah,
majority of the time you'll be spending on the data
yeah,
engineering part. Yeah,
yeah.
yeah, fair enough. Adim, you want to go next?
Yeah, hi. I'm Adim. I'm working as a PLSQL developer in NIT. I have 5 year experience, and apart from it, I have a basic knowledge of data science and ML and deep learning. And apart from it, I'm working on a research project with my friend. We're doing a PhD
Mm.
from Aligarh. So I'm helping the research as a part of our data science
Okay,
side. Yeah.
okay. Any programming like background?
PLSQL and Python.
Okay, Python. Okay, and expectation from this program?
Actually, I want to switch to the data science. More want to move to data science. That's
Okay, so a lot of hype around DSI. Everybody want to go to data science.
why.
Okay, nice. Okay, fair enough. Ashutosh, you want to go next?
Yeah, hi. So I have a background of databases, database administration, and I have 5+ years of experience. And like to move with the course is definitely to look into more of the playing with the data science, and along with the Python. So that is my goal, to look into it, because I don't have any, I haven't worked on any programming language. So that would be my another thing to look into it.
Okay, so generally database admin people, they do some they do some shell script kind of work to automate the stuffs and all.
Actually, I didn't play much with it.
Okay.
I tweaked a couple of scripts, but never actually created something new of my own.
Okay, fair enough.
So yeah, so something I'm looking into the course is definitely to at least like the thinking pattern of how to look into the code or how to see the code or how to write it as well. That is also the
Okay, but
something
you
I'm
are aware,
more
like
looking
means
forward to.
in data engineering,
Yeah.
we do a lot of programmings, but yeah, means we not at an algorithm level. So I don't want to give wrong information. Some people say without programming also we can do data engineering and all. For course sake, I will not say that false thing. We do a lot of programming, but at the same time, so there are two type of programming. Like in software engineering, people they do some programming, just like Abhishek mentioned, like he has done some microservice development using Java, Spring Boot, and all. And also some product-based companies, software engineers used to develop algorithms and all. They do play around with different algorithms to optimize their code and all. And in the other hand, the data engineering, like we like people, we also do the code. But our case, we don't do a lot of like algorithms or data structures related stuffs. Rather, we do play around with our data transformation logic, which is also programming, but way less lengthy or complicated than the software engineering people what they do, right? So even though a person doesn't have any programming background, we can spend a weekend, we can learn Python and we can start developing big data projects. Okay, so but in terms of for software engineering, you have to spend a lot of time understanding the programming language, and on top of programming language, there are different frameworks are there. Just like on Java, you have Spring, Hibernate, and all this. On Python, you have Pandas, data frame, NumPy, and all, right? So similarly, we have but here in data engineering, we have to understand the scripting part or the core part of Python, and that should be good enough to start with the programming. So I would say you can start spending some time going through YouTube videos, like what is means how to write basic programming. Like you can the people who doesn't have any programming background, you can start with basic programs like how to write a program to check if a number is prime number or not, if a string is palindrome string or not. So those kind of very basic programs you can start with Python. Basically, how to declare variables, if else statements, loops like for loop, while loop, and all this. Yeah, so list, set, map, these kind of collections. Just spend some time. Anyway, we have 4 sessions dedicated for Python. But yeah, we are not directly starting with Python. We'll be directly starting with Spark. But after continuing 6-7 sessions, we'll take a pause and we'll go through Python. So I would say like you can spend some time understanding the Python part. Okay, so some
Yeah, the
basic
basic
program.
structure is already, I know that what is list and tuple and all these things.
Yeah, exactly.
That's
They
fine.
are there in the SQL also. Yeah, these are there in the
Okay.
SQL also, right? So we can declare columns of type list and set and all this. Okay, but yeah, so just try to don't install any lot of things are there. You know, like you can search Python online interpreter and you can start writing program and you can start doing hands-on without installing anything in your system also. Okay, anyway, that
Okay.
I'll get you through. Okay, fair enough. Yeah, Himank, you want to go next?
Yeah, hi everyone. I'm working in a USB startup called Cerebron.ai and I'm a DevOps engineer. Basically, my work is to deploy the on-premises solutions to the cloud, migrating to the cloud, and then deploying the microservices architecture on Kubernetes and creating the pipelines for them, CI/CD pipelines for them. So recently, we were working on some project where we deployed pipelines using Jenkins, and then I have also exposure to the cloud, like basically all the 3 clouds: GCP, Azure, and AWS. Yeah,
Okay.
and I also have like basic knowledge about Python and shell scripting also. Like I also created scripts using Python.
Okay, fair enough. How many years of experience you have now?
1 year experience.
Okay, you're also a fresh graduate, 1 year experience.
Yeah.
Okay, fair enough. Yeah, so what's your expectation from this program?
Yeah, my expectation was like I wanted to like there is a lot of interest going on towards the data engineering, and I wanted to learn about the data engineering, how data engineering works, because it's all about the data. So in like near future also data will be increasing more and more. So we should be knowing how data is getting processed, how it is uh, moving towards the cloud. So that's what my expectation.
Okay, okay, fair enough. So you're also based out of US, right?
Yeah. No, I'm in India.
Okay, you're in India. Okay,
Yeah.
okay, fair enough. Yeah, Manjunath.
Hi, my name is Manjunath. I'm a recent grad in computer science. Like I did my master's here. I recently started working as a data engineer. So yeah, I wanted to learn more, get into more into data science. Like I have learned more of like my machine learning kind of stuff, like data science, but I want to understand the data engineering stuff as well. So yeah, that's why I don't join
It's programming language and
Python
okay,
and SQL as well.
fair enough. Okay, fair enough. Raj, you want to go next?
Yeah, so I work so I'm currently working in RGA. I work as a cloud and ML ops person, but I support data science team, so I provision infrastructure for them, but I'm also a founder of a startup called Cerebron. So I do a lot of DevOps and cloud, and I'm based out of US. I do have like 3 to 4 years of experience working with cloud, and I also do my PhD. I've done a lot of papers on deep learning, machine learning, but data engineering is the field which I'm not too involved with because of my limited exposure to the industry in the data engineering, especially with Spark and all the cluster provisioning. I'm good with AWS data pipelines and automation. I'm not a programmer, so I don't do programming on day-to-day basis, but I do understand most of the programming languages, and most of the time I usually am interested in learning new technologies, implementing them, and also the primary agenda to join this training is to ask questions and also to learn, especially what they do in industries, because currently I do see data engineering team, but I'm not sure what they are exactly doing in terms of like what Spark is used for. I know concepts of RDDs and things like that, but I even have a few more questions and doubts, and probably I'm hoping this training would help me out with those.
Okay, nice. So you are running your own company and all, you're saying, right? Cerebrum or something like that.
Yes. It's a basic startup. It's just Abhishek and Himang. They both are part of my firm, so we are slowly growing. We do have some projects in ML, and
Okay,
probably
so
we'll be getting into data engineering pretty soon with other projects. Yeah,
you got funded, or like it's like you
it's my own funding. I'm pretty much I have my own funding, and I do have investors who would be pretty interested, who are going forward. We are expecting them to be part of our firm, and I do am having some collaborations with my university in the US. So we are also going through some programs here as well in the university.
okay, fair enough. Yeah, nice. Yeah, Sai, you want to go next?
Hi everyone. I was pursuing my master's right now currently, and I was have developed skills in MySQL and Python, and I was right now I was learning freshly basics of ML. I was going through, so I thought like why don't I start with data engineering, because the basics first of all before learning going into ML and depth of the implementation anything, but learning about data is more important for us, how it works and starting with basic stage. So I thought of why don't I try big data.
Okay. Okay, fair enough. So you're a fresh grad. So you're based out of India or US?
I was pursuing my master's right now in UK.
Okay, UK. So what's the time here now?
I was in second year right now. I was currently on internship.
Saying like, what's the time now? Here in India, it's
Oh,
8:30.
right now it's just 4 o'clock.
Okay, 4
morning.
o'clock. Okay, morning 4 o'clock. My God, it's too early for you, right?
Yeah, it's okay. Yeah,
Oh, okay, okay. That's really how you'll be managing. So
it's okay for me. I can manage it. I'll somehow figure it out.
okay. Okay, so you're a fresh grad, you are doing your master's there in UK and you have some background in SQL, Python, basics of ML, and you want to move into that. That's why you're learning big data. Okay.
Yeah.
Okay, fair enough. Tausif?
Hi everyone, I'm Tausif. I'm working as a tester. Hello.
Yeah.
Yeah, I'm. I have like basics of Python and Java and SQL basics, and I have 1 year of experience, and I just want to move towards data engineering roles.
Okay.
Yeah, that's it.
Okay, fair enough. So 1 year of experience, you are doing testing. You're currently working as a testing engineer, and as part of your testing activities, you must be doing some automation using Java, what you call Selenium and all. So that's why you're using Java, and some experience in Python and SQL also. Yeah, all these are part of testing activities. You to query the data to validate and all. Okay, fair enough. And you want to move to data engineering.
Yeah.
Okay, fair enough. Sanju? Sanju, you're there? Your voice is not coming. There's a mic problem, I think.
Hello.
Yeah, it's good now.
Yeah, sorry. I was on mute. Yeah, so my name is Sanjog. I am currently working as a data engineer in North Carolina, USA. I have around I have around 2 years of experience as a data engineer, and I have around 3 years of experience as a SQL developer and as a data analyst at the same time. So yeah.
So your total 5 years of experience or hard test?
Yeah, 5 years of experience total, and I've done my master's in US.
North Carolina that's Charlotte, right? We have a lot of people from those areas.
Yeah, I live in there's a place called Research Triangle Park near like all the IBMs and big tech companies are nearby. I live somewhere near in Raleigh, North Carolina. Yeah.
Okay, North Carolina. Okay. So, okay, fair enough. And your expectation is you are already into data engineering. So, what's the intention behind
Yeah, so I am so our company is migrating to cloud platform. We were using like Cloudera, so we are trying to move into cloud. So I don't have much experience with cloud, so that's why trying to learn all AWS stuff here.
Okay, so you have any programming background also?
Yeah, we use PySpark, Python, SQL, shell script here, Hadoop, basic text data engineering tech stack.
Okay.
In my company, yeah.
Okay, fair enough. Yeah, got it. So already into data engineering and you want to, the cloud part is missing because nowadays data engineering is by default attached with any of this cloud, either AWS, Azure or GCP. So now it's
Yes,
a
correct.
kind of combination. Nobody's using on-premise because of the obvious reason. It's very costly, like if
Yeah.
you're doing it on-premise. So if the data set size increases, you have to keep on adding new machines, and it's very difficult to small or mid-sized companies to manage these use clusters. So even big firms are also moving to cloud-based solutions. They don't want to handle all this infrastructure by their own. They want to delegate it to cloud providers. Okay, fair enough. I can understand. Yeah. So Vikas, you want to go next?
Yeah, hi Siddharth. Hi everyone. So this is Vikas, and I have around 8.5 years of experience in testing. So that is including automation as well as manual. So I have fair knowledge about Java programming, and my main intention is to transition my career from current profile testing to data engineering services. But yeah, I don't have SQL knowledge, yeah, because I have hardly used that.
Okay. Okay. So Java means Selenium and all for that core Java you are
Yeah,
using.
correct. Yeah, yeah.
Okay. Okay. Fair enough. So 8.5 years of experience. Yeah. So what I can see, two people are having so basically testing background, and most of the people are having, and another half people are having some development or DevOps background, and some people are into already data engineering. Okay, so people who don't have programming background, I would say directly start with some basics of Python. Okay, spend at least a day, few hours to learn like Python basics, how to declare a variable, how to write if-else statements, how to write for loop, while loop. These basics only required. Okay, so the rest of the things we will be discussing here only. Okay, so fair enough. So we just got each other's background, and I'll just format it and we'll share it over the group so that you can keep it as a reference for future use and all. So with that, let's start with the today's part. So today's basically we'll be discussing about the course content. What are the stuffs we'll be discussing today? And yeah, I have just a habit of keep on speaking, but you have to feel free to interrupt me. Okay. So because it's a completely interactive session, you are not going through a self-paced manner and all. So you are going through a interactive session. So feel free to interrupt me whenever you see you have any doubt, or you want to basically discuss further more. So you can basically interrupt me there. Okay. So this particular course is I've created for complete end-to-end big data developer role. Okay, so initially I started it with, and one more thing I just missed. So people from US who need any placement assistance, like they're pretty much easy and all. But yeah, still, if anybody requires placement assistance, like I'm associated with like 3 consultancies there. So I do help with the placements and all these things also there. So feel free to reach out to me if you want to get into big data roles and all. So we have very good network, like 3 Indian consultancies who do hire this OPT, CPT students and help them doing placements. H1B also. So just let me know if you need any help. Okay. So we can do the
Yes.
placement. Yeah.
What kind of consultancies? What all consultancies you deal with? Wisen IT, XRIT?
There are 3. One is Extract IT. That's again done by Mukesh. He's I think Hyderabad. And another company is Tech Ninjas. That's again run by Vasant. I'm not sure from which place. I heard they have office there in Bangalore also. And the third one is WAC IT. WAC IT is also run by Raj. He's from Hyderabad. And yeah, WAC IT, Extract IT, and yeah, these are the companies. So means placement maximum 1 or 2 week we can do the placement.
Okay. Okay. Yeah.
So that's there. So with that, okay, just let me know. It's pretty straightforward. We have done multiple such. Okay, every month almost 20 people are rating. At least 10-15 people are rating list. Okay, so in US it's very easy. Okay. So without further delay, let's start with the course content part. Course content part. So basically, this course has been designed in such a way that people from only working people. That's why I always target working people. So here also pretty much all are working people only. So in people who are doing USMS fresh graduates, they're equivalent to like one year experience here in India itself. So I'm only targeting experienced folks, and we do I do walk them through the entire content required for a person to show at least a genuine 3 years of experience into their profile, and you can start marketing and you can start applying for jobs. Okay, so all these aspects require like for a like 3-4 years 5-year experience guy. So what are the contents we need to know? Like we need to understand a project from the scratch. Like if a fresh project comes to you, like how to basically decipher that project, how to understand the requirement there, and how to figure out like how to solution it, like what are the technologies to be used and all. Okay, and then develop the entire project. Okay, so data engineering project, if you have heard, like many data engineering projects are very small projects, like 3 months 4 months project, and we have to 3 months 4 months project, and we have to work really fast and deliver it. So in fact, like that's when you're in there in US also, you'll see many contract roles are coming, like 4 months 6 months 8 months, like that, because they're very short projects. So means you'll be having a understanding, like you can develop the entire project end to end. So it's not very difficult. When just like in your college time, you have worked on different algorithms, you open your IntelliJ or Eclipse, write the program for Quicksort and run it. Similarly, you'll get an idea, like if somebody gives you a project like data pipeline project, how to do the data ingestion, data curation, data provisioning, you can write all this code and you can deploy it to AWS cloud, and you can automate it also. You can basically automate the stuffs pretty much, like say you want to run every day, you want to create a cluster, run the job, and the data will be updated in the final warehouse, and then you terminate the cluster. So entire thing automated. So all these things will be getting idea. In fact, we'll be doing hands-on itself in your own system, in your own AWS account. Okay, I will not do anything in my own AWS account. So every day I will take one person's system, and we will do the entire programming, entire hands-on part on that particular person's system. Okay, I never do anything in my system. Only today you are seeing I'm sharing my screen, but tomorrow onwards, every time I'll be picking up one person's system and I'll run the code. Okay, so that like if you have any queries, if you are missing something, some other person will stuck there, and that question will come to me, and we can solve it. Okay, so everything you will be executing. So you got my point, right? Means just like software engineering people, what they do, they create different software. Software is as in not exactly you are creating some products and all. So that we do in product-based companies, and in consulting firms and all, you do create different systems. Maybe you create the backend services, whole bunch of microservices for any web application, or you are doing some other stuff like for example, you are writing the backend code, the data, the movement of data from the UI to backend and vice versa. Those kind of stuff you're doing. And some software developers create UIs. So there are different UI frameworks like AngularJS and all these stuffs that also people do. And just like database developers, they do create different schemas, create tables, and optimize the queries for read write and querying the data. So similarly, we data engineers create data pipelines. Okay, we'll discuss like what is data pipelines, but for now, just be familiar with the wordings what we are using. Software engineering people developed softwares or the backend codes or batch applications and all, or UI front-end applications and all. Similarly, we data engineers, what we do, we create data pipelines, and which has three aspects. So bringing the data from the source system to the lake, that is the data ingestion, then doing the data curation. Once you have a whole bunch of business logic to transform the data from the source format to an analytical format, so that a lot of analytics can be done on that data, and then you publish the data so that the analytics team can consume the data from that. Okay, maybe visualization teams, Tableau, or those kind of dashboards, they can consume the data from there, or ML machine learning people, they can also do their analytics or modeling on that and all this. So as a data engineer, our job limited in this area, like bringing data or doing a data ingestion, doing the data curation, and make the data available for the downstream applications to consume. Okay, we'll discuss in more details. So the idea is basically all these three aspects you should be able to do it end to end. Okay, so we will be executing almost 150 examples here, and you'll get fair idea like what are the different type of problems can come, or what are the different type of transformations you may have to do So you'll be able to implement that logic by your own. And also the automation part, you can deploy the application into cloud, like EMR cluster, AWS EMR cluster, and you can automate it using step functions and all these things you can do by your own. Okay, that's the whole idea. Okay, with that, I'm starting with how I've broken that entire stuff into smaller pieces or different modules. So first, we're starting with the Spark core part. Okay, Spark is the most popular and one of the very popular and stable distributed computation framework. Okay, just like you, many people mentioned, like they have some Java background, Python background, and all these are different programming languages. So, but Hadoop, Spark, Flink, these are different distributed computation frameworks. Okay, we'll discuss that in details. I'm just giving a very high level overview today. So Spark is a distributed computation framework. We use Spark framework to write programs to process huge amount of data and complex business transformations, and that's Spark is all about. And we're starting with the Spark from the day one. We'll be starting with Spark without going through Python and big data theory and all. So slowly, like during the programming itself, I'll be explaining what is this and that and all this. So we are starting with the Spark part initially. So the first part is basically RTD. Okay, so we are saying we are processing huge amount of data and doing a lot of transformations. Okay, means we are doing a lot of aggregations. We are deriving new columns and all this. Okay, you are applying a whole bunch of analytical functions, window analytics functions and all. So for that, there are two approaches in Spark. One is through a collection approach. You can basically read a huge data as a collection, huge collection, which is shared across multiple computers' memory, and apply the processing step by step. And another approach is basically you can read the data as a table, or we called it as data frame. You read the entire data as a data frame and then apply transformations on that. So it will be the first part is basically this module one is basically RTD, which is a collection approach. Okay, we'll be reading the data as a huge giant collection, and then we'll be applying transformations on that using the normal Python lambdas, okay, Python functions. Okay, so with that we'll be introduced into the Spark framework. We'll be doing some programming. So I do follow the other approach, like a bottom-up approach. First write the program and then explain what you did, and slowly connecting the dots. Okay, so in real-time projects, this is the type of problems we have, and this particular program fits here. Okay, we solve this kind of problems in this way. That's the whole idea. Okay, so we are starting with Spark's RDD, resilient distributed data set, which is nothing but a huge giant collection, and that collection, on top of that collection, we're applying data transformations.
Siddharth, sir.
Yeah, please.
Yeah, the collection of what? Like RDD is a collection of
data.
Which
so
data
example,
in the data in homogeneous data or heterogeneous data? Like if you say collections, then collections. If we take a collection, like collection can be elements, collection can be array of elements, collection can be homogeneous array of element or heterogeneous. So exactly, what is exactly the collection in RDD stands for? Like which collections are we talking about? Data in the form of what?
Yeah, I got your point. So we'll start with very simplistic examples to more complex stuffs. So as you rightly pointed, like data can be of any type. It can be homogeneous, it can be heterogeneous, it can be like that. In big data context, we call it as structured, semi-structured, or unstructured data. Okay, so we can process any three kind of data. So, but as you know, like since we are working for different clients, and clients are different enterprises, and you know, enterprises always store their data in a proper tabular format. It's always structured or at least semi-structured. With the rise of this NoSQL databases like MongoDB, Cassandra, and all, so enterprises also started storing the data in a semi-structured format. So 99% of projects what you'll be executing in different companies with different clients are basically structured or semi-structured data. It's purely two-dimensional table. So, but it's not limited to a single machine. Rather, it's spread across tens or hundreds of computers. You read that data. Say you can take an example of say Citibank. Citibank's transaction data. If you just take an example of Citibank US, and they want to do a lot of analytics on their data set. So what they can do, so you have to basically, they're saying like they want to create some machine learning models to do some forecasting, or they want to understand few patterns there in the data. So they have to read that data and do all these transformations, all these analytics on that. So there I'm saying like you read the whole transaction data as a RDD or as a collection, and then you keep on applying different transformations to say find out say monthly total debit, total credit, say monthly total new customers getting added to their banking system, or monthly or annually how many loans they're dispersing. So all these kind of analysis or all these matrices you are capturing, so that you can program using RDD's transformations and all. Okay, and similarly, semi-structured data. Semi-structured data is basically I'm saying you have like MongoDB or Cassandra or JSON files. Okay, so these are semi-structured data. So where the data is not a very strict schema, just like RDBMS, like Oracle, MySQL, and all. It has a fixed schema. You create an employee table having employee ID, department ID, salary, and all these columns, and you mention that this column is unique, this column is primary key, that column is having a range of this and this. So it has a very strict structure. It should be always two-dimensional and with these additional constraints also. But here in NoSQL databases, it has a schema, but not very strict. Okay, if it is having no schema at all, that means it's quite unstructured data. Like you are reading a paragraph in Wikipedia, or you are reading a Facebook feed, or you are reading a LinkedIn article. So these are unstructured. It doesn't have any structure. They're paragraph, kind of very much text data. But this kind of NoSQL databases or basically JSON, these are semi-structured data. You have a fixed structure, but it's not very strict. Okay, so some columns can be missing. So few records can be having additional columns like that. Okay, so the moment I'm saying like we will be reading data as a collection means that. So we'll be reading those data and we'll be creating a huge distributed collection out of it. And then we'll be applying transformations one after another until you reach at the final stage. For example, the same discussions what we had a Citibank's transaction data last 10 years, and somebody just asked us to do some analysis. So say the person want to find out the total number of personal loans disbursed at an annual level and total number of new customers they're acquiring every quarter, or total revenue or total profit they're making every 1 month. So all these matrices they have asked you to calculate. So for that, what you have to do, you have to read the data from their system, create a collection out of it. Then you will be applying transformation. Say the transaction data has 20 columns, but you are only interested in transaction month and the transaction amount and transaction type. So you only select those columns from that data, and then you do apply aggregation. Say you want to apply aggregations basis the month and the customer ID, and you want to find out the sum of transactions, or you want to find out the count of unique customers. So then you can generate the output and you can write it back to another file like that. So those, I mean, a series of transformations. You read the data as a collection, apply a whole bunch of transformations. Transformations are the people who doesn't have a data background. You can think of like you're applying different functions on that, and keep on applying these functions one after another until you reach the final output what you're looking for. Okay, we'll discuss that in more details. So this, so you might be wondering, like, we didn't do any setups and all. So you're saying we will be executing program from tomorrow, but we don't know what's the type of laptops we require or what's the type of configurations required. So we'll do that later, but tomorrow. So as you know, like big data is not new in the industry. Like Hadoop, the first open source distributed computation framework, came in the year of 2000. It's almost 21 years back. So it's not new. So there are a lot of open source open communities are there. So among that, like Databricks is also one. Databricks provides you a free platform where you can write your Spark program and execute it. Basically, learning purpose, they're giving you one free big data cluster where you can write the program and execute it. Okay, I'll walk you through how to register. It's pretty much easy, like just like you are registering to Facebook, even further easier than that. Okay, you can just provide your email ID and password and you can create an account and you can start practicing your programs there. Okay, so that's basically all about your, so we'll create our own Databricks account and we'll write all these RDD programs there. Okay, as you have discussed earlier, like we don't have to. So as the first four sessions are like demo sessions, so I don't want to spend time doing the setup. So post RTD part, then only we do the environment setups. Okay, so
Siddharth, sorry to interrupt this, Vikas. So,
yeah, please.
Siddharth, since Databricks is you said one node cluster, in real time, how many clusters do we use means while working?
I have worked. Means I'm currently working with a client, US bank, where the clusters are pretty much like 1,000 node clusters also. But I have architected some project and end-to-end executed some pipelines with maximum 70 node cluster, where each node is having 16 core and 64 GB of RAM. So we'll discuss that in details, like how do you decide the cluster capacity and this is the complexity of the job and all. Okay, so these are basically for sure we will be discussing. These are all interview questions, and we also should know as a experienced persons all these details should be required. So we'll discuss that in details.
Okay, so we'll be practicing directly on the Databricks interface only.
For RDD only, we'll be using Databricks. After RDD, once we'll start the Python part, the second module, everything will be starting with your own computer. You will be installing PyCharm, and on PyCharm with Python 3.7, we'll do all this programming in a local computer.
So we do not be needing any SDFS whole ecosystem kind of thing that we are talking about.
That thing we will be using AWS. So once the Python part is completed, Python doesn't require any AWS and all. We'll simply install Python 3.7 PyCharm and we'll practice the program. And then we'll start with the data frame part. So there itself, I'll help you through like how to set up your own AWS account, how to create your own Elastic MapReduce cluster, all these things, setups like. So this first module, everything on Databricks. Second module, everything on your local computer PyCharm. Third module, all this development will be done in the local computer using PyCharm and Python 3.7, but the execution will happen on AWS. Every time you write every time you write a data frame program, you will be testing that program on AWS EMR cluster. Okay, every day.
But in real time, how you guys work with, is this
Exactly
the process
same.
you follow?
Exactly
Okay.
the third approach what I mentioned.
Writing in the local and executing in the on the AWS.
Exactly. This is my personal computer. It's not my office laptop and all. So here what we do, suppose we do the development. This is a Scala project. So you do the development in your local computer. So that's a PyCharm or IntelliJ. And that code is basically synced up with your code subversion, that is Git repository. Okay, so Git is a code repository, code subversion. You will, every time you make a change, you push the code to Git. And then you in a terminal, you will be connecting to that particular master node. Okay, you will find a black and white screen where you just do a SSH connection or putty connection to the cluster's master IP address, and there you will check out the code. Okay, so your code is now in Git. Okay, from Git you will pull the code. Okay, Git clone and Git pull. So the code is now available on the master node of your cluster, and there you execute the Spark submit command.
Okay. So we won't be using WinSAP and Putty. These things means we won't be needing.
If you are using Windows, you will be using Putty and WinSAP. WinSAP not required. WinSAP is required to transfer the file. So, and as you know, like we are saying, our code will be there in the Git only. So you can use Git command to push and pull the code from local computer to the master node's file system.
Okay.
And if you're using Unix-based systems, most of the time big data developers are provided with Ubuntu or Mac. So what we do, you don't require this putty and WinSAP. You can directly do it through your command prompt, your console. Okay. So you can do a SSH connection to create a terminal or create a session, or you can use SCP command to transfer the files. Okay. So, but yeah, if you're working using Windows computer, you have to use putty and WinSAP.
Okay, got it.
Okay, feel free to interrupt me. Okay, other people, nothing to hesitate. Don't feel like people know everything. So we are all here to learn. Okay, so nothing to hesitate. Okay, any question comes to your mind, even though you feel it's silly, still ask. Okay. So I know that.
So that you will be teaching means what is cluster, what is group of cluster, what is partition, everything you will be covering up means that part.
These are bare
Although I
minimum.
have studied.
These are bare
Sorry?
minimum. These are bare minimum. You have to definitely understand those things.
Well, I know. I don't want to, you might be going in depth in these things, but just give me a very small difference really fast between data frame and RDDs. What could be a
Yeah.
just
So
a one line?
yeah. So as we are discussing, first we'll be starting with the RTD part. Here you are reading the data as a collection. Okay, collection means if you have programming background, if you see like in Java you create list set, or in Python you create list set, and then you apply transformation. In Python, how do you apply transformation on list? You call map function, map, and you pass a function, comma, then a list. So that means what happens? This map function will apply that function to each and every record of that particular list.
Yeah.
Okay, people who don't have any programming, some basic knowledge in Python, you must be knowing. Suppose I have a list.
1, 2, 3, 4.
List of
1, 2, 3, 4.
1, 2, 3, 4, and I want to apply. Say I want to add 1 with each and every number. So what I can create, I can say call equal to
map.list.
Map of, say, other people don't worry, we will discuss all these programming details. Lambda say record colon record +1. So this is the function. So what it will do, and then I'll be passing the same list itself. So what it will do, it will take each and every record from that list. Okay, this record stands for each record, like 1 or 2 or 3 or 4, like that. It will keep on iterating through each and every element, and it will add it with 1. Okay, and then it's basically creates a map object, and you have to convert it to list. Like that. We do apply transformations on each and every record of a list. So RDT is pretty much same. Okay, here it's a single standalone list, but there in RDT it's a huge giant list having billions of records and millions of records. That means it's scattered across all computers' memory. Okay, but everything is abstracted. For us, it's just a list, and we are applying transformations on each and every record. And in the other hand, in the data frame, we read the data as a data frame or a table, you can say. In RDBMS structure, we call it as a table. You read the entire data as a table, and then you can apply transformations using some functions or some SQL queries. Okay, it's a two-dimensional table, and you can apply once you, that means two-dimensional table means there is one limitation. So here in terms of in case of RDD, you can pretty much read a structured, semi-structured, or unstructured data and create a collection out of it and apply transformations on each and every record. But the moment you are saying two-dimensional means it can be only structured or semi-structured data, no unstructured data. Okay, you read the data and it's pretty obvious because, as you know, enterprises always store the data in a structured or semi-structured format. So banks never store the data as text file for their transactions and all. It's always RDBMS table or NoSQL databases, right? So it's a two-dimensional table, and you can apply the transformations using object-oriented programming or SQL.
Yeah. Okay. So I think that explains why I see a lot of RDD data frames when dealing with machine learning, but I never dealt with RDDs in machine learning.
That's correct, because RDD we never use in the real-time projects. In the projects, we always use data frame. Then when the question comes in, like, why RDD is there? So Spark's initial versions was only on RDD. So they started with a framework which supports only RDD. RDD is basically the white paper for them. They published there in MIT as a distributed computation, which later they gave it a name as Apache Spark. So that is basically for every kind of data you can process in a distributed manner. But data frame is when you are talking about when you are working for enterprise projects or client projects. These are all structured or semi-structured data, and people who are already into data area, like a ETL developer or a person who is already doing Informatica and all this stuff. So they have their core expertise around SQL, or some people from normal object-oriented programming like Java and all. To make Spark framework easy and to make the Spark framework easy, they just published a new data abstractions data frame, and that's why like many developers community jumped into Spark and they started developing Spark projects. Okay, but in real-time projects, we do always use data frames because the data is structured or unstructured, and the complexity of the transformations what you're applying, it's way easy in data frame in comparison to RDD. I'm not saying it's complex or simpler. So because the definition of simple or complex is basically our own understanding. If you understand something, it's easy. If you don't understand something, it's difficult. But it's actually not in that sense. Rather, you would say the same transformations what you're applying in RDD will you may require a lot of lines of code to write to achieve that. Whereas the same thing can be done in data frame with few lines of code. That's the whole difference. Okay, and it of course comes with a lot of optimizations and a lot of flexibilities and all. Okay, so pretty much all kind of mathematical functions or like any aggregation functions you will look for, you will get it already defined here. Okay, but in case of RDDs, you have to write most of the function by your own. Okay, like that. So these are a couple of differences. Okay, so with that, so I have to finish this course content anyway today. So first part is basically RDD. We will learn how to read data from different systems, okay, and create a RDD or a distributed collection out of it. Then you apply transformations on that. Okay, then you apply transformations on that. So we'll be playing around with data using this RDD or the collection approach. Okay, through that we'll be learning all these stuffs like what is this distributed collection, okay, what are these transformations and all, what are the different type of transformations are there. Okay, so every time you execute a Spark job in the backend, how it executes, is it like traditional programming, line by line it executes? You write up 10 lines of Python code, first it will execute the first line, then second line, then third line. Is it same like that or it's different? Okay, if it is different, then how it is, how it decides that execution architecture. Okay, all these things we'll be discussing here only. Okay, we'll be trying basic transformations, like say for a given data set, what's the total sum of transactions. Then little deeper, for a given data set, what is the total sum of transactions at a yearly level or at a customer ID level or at a product level. Okay, then at a further deeper level, then we'll be seeing like how to pivoting the data and all this. Okay, so we'll be trying different type of data transformations using RDD approach, and here also we'll be discussing the execution model. Okay, so every time you submit a Spark application to a cluster or to its execution environment, how it basically executes the job in the backend. It's a very important thing we need to understand, because if you understand that only, then only we can do the optimization. Okay, so a lot of things are there. We'll discuss here, like you have a huge data set, but you have a small cluster. You have to process 100 TB of data, but your cluster is having only 20 GB of RAM in total or 50 GB of RAM in total. So will you be able to execute it or not? If you'll be execute, then how it is possible? Okay, you should be able to explain them all this. Okay, so these things we'll be covering during this first 6 to 7 sessions of RDD. Okay, here only I'll make sure like everybody able to write the program by their own. I do make sure like we do hands-on here, and I give assignments, and I do take control of a person's monitor, and then I write all these programs there. Okay, just trust me, like the first 4 or 5 sessions objective is to make sure like everybody is comfortably able to write programs. Okay, then we move to the next part like Python or data frame part. Okay, so post that we'll be stop using Databricks, and we'll be doing all these setups in a local computer. Okay, so we will be using the local computer. We'll install Python 3.7 and PyCharm, and then we'll start using PyCharm to write the Python programs. Okay, we'll be writing the programs in Python. What we'll be discussing, the core part, okay, how to declare variables, if else statement, for loop, while loop, okay, and all these collections, okay, set, list, set, tuple, dictionary, and all these, and object orientation part like class, object, decorators, and all these, and some advanced concepts like generators, comprehensions, exception handling. All these things we'll be discussing here. Okay, so that is there, and so with that, like it will take 4 sessions for us. Okay, so RDD 6 sessions, and this Python will take 4 sessions, and post that we'll be jumping to the data frame part. Okay, so you can see working with structured data using data frame and AWS cloud. So while starting the third module, we'll first do our own AWS setup. We'll all create our free account. There are certain services free or certain services paid. Okay, but I'll see, like I will discuss how to avoid the cost and all, how to avoid the payment, but still using the AWS for our learning. Okay, so we'll start with the data frame part. We'll first do the AWS setup. We'll create a cluster. Okay, so as we are discussing, this is distributed programming. Distributed programming means what? What is distributed? Your computation and storage are distributed. Distributed by what? By multiple computers. Just like traditional Java, Python, SQL, these are all standalone in nature, right? Means you install JDK on a single machine and there you execute a Java program. You install Python kernel in a machine and you execute Python programs there. You install MySQL database server in a machine and you create tables and write SQL queries, and these are executed on that machine, right? You are an Informatica developer. You install Informatica on a premium server, a huge server having say hundreds of GBs of RAM and hundreds of cores. And there you install Informatica and then you start using Informatica. But still these are all standalone in nature, right? But the moment you are talking about distributed computations or Hadoop, Spark, Flink and all, these are distributed. Means you can store data on multiple computers and still get a unified view of that. And you can interact, or you can do IO with that data in the file systems. Similarly, when you are executing the programs, also same thing. When you are executing a program, whether it's an RDD or data frame, it all executed in parallel in a distributed manner. Okay, hundreds of computers are executing your programs in parallel in a distributed manner. What's the difference between parallel and distributed? Parallel means at a time, say for example, I'm giving a very high level overview. You have written a job of 100 lines of code, and in the backend, Spark just broke that into say 1,000 smaller tiny tasks, very small 1,000 tasks. Okay, and you have a cluster having say 10 node. Okay, and you have a capacity to process 100 tasks at a time. That means this 100 tasks will be always running in parallel. And what is distributed means you have 1,000 tasks to execute. So first 100 tasks will be executed, then 100 tasks, then 100 tasks. Like in that way, in round robin fashion, it will execute all 1,000 tasks, isn't it? That's what I'm just saying. Okay, so those are the steps. Like we'll learn like how to set up our own EMR cluster, Elastic MapReduce cluster over AWS. We'll learn how to move our code from our local system to that EMR cluster through GitHub, through Git, okay, Git code version. Okay, you'll also learn some Git commands like how to create your own repository, how to push your code, how to pull the code. All these things also we'll be discussing. Okay, and then we'll be pulling the code there in the EMR cluster and run it. Okay, so all these things we'll first learn in manual way. Then we'll be doing the automation manner. Automation means you can write a script. Okay, every time you go to the AWS account and make few clicks to execute to create a cluster, rather you can write automation script also. That's one of the biggest reason we are using cloud instead of on-premise, because everything can be programmed there. Okay, but that cannot be done in on-premise. Okay, in on-premise, for example, you are setting up a 100 node cluster. Okay, you have to procure physically 100 computers. You have to purchase from the market, and you have to format them with operating system, say Ubuntu or CentOS operating system. And on top of that, you have to install Hadoop's cluster called Yarn. And then you have to implement the security stuffs. You have to create users, give them access. Right users should get the right accesses. All these things you have to do. Everything is most of the time it's manual. Okay, not most of the time, it's always manual. But whereas the same thing can be done in cloud with automation script. You can write a script that script can create a 100 node cluster on the fly. You don't have to go to the EMR console and pick 100 machines and set up a cluster. No, you can write a script, say 10-line script, and that script can create 10 node cluster in 5 to 10 minutes for you. Okay, you can implement auto scaling. Say workload is increasing on that cluster, so every time it's increasing, it add 2 more node to the cluster. Everything can be automated. Okay, and the entire infrastructure can be programmed, isn't it? So those things also we'll be discussing. We'll be creating a AWS Lambda script, and there you'll be writing instructions to create a 3-node cluster, and you simply click a test button, it will create a cluster for you. Then you start using that cluster.
Yeah. So that I have a small question.
Yeah,
so when you deal with EMR, then there is no need to deal with the Yarn or Pig or Hive, things like that.
So there's no need to, it's a managed cluster. It's a managed.
Yarn related to the infrastructure, whereas Pig and Hive, because I don't see those in your code, so I'm just presuming probably because of cloud, they just we are just not dealing with those. Am I assuming right?
No, it's slightly different. So basically
Okay.
what we are doing, so for example, you are running a Java program. So you require a JVM, Java Virtual Machine, to run your code. You are executing a MySQL or SQL query. There should be a MySQL query engine to process your query. You are writing a Python program. There should be a Python kernel to execute the Python code, right? Similarly, when you are writing a big data code, doesn't matter it's a Spark or Flink or Hadoop, MapReduce, anything. So unlike the traditional programming, which has different compilers or execution environment, but here in big data, all are running on the same platform. Okay, their execution engine is same. That is called cluster or YAN cluster, YARN, YAN, yet another resource negotiator. YAN is the cluster. On top of that, you can execute your Spark program, Hadoop MapReduce program, Flink program, Hive queries, Pig script, anything you can run on that. Okay, so the moment we are saying we are creating a EMR cluster, that means we are creating a YAN cluster. Okay, so while creating the EMR cluster, you can specify what are the services you need. So you want on top of YAN, you want Spark, you want Hive, you want Pig, you can specify that. So while creating a cluster, it will add those libraries there and we can start using it.
Okay, so Pig, Hive, those could be runtimes. So Yarn could be the cluster that is providing. And
no, YAN is the runtime. YAN is the runtime.
Oh, Yarn is a runtime because of that is
Spark,
negotiated
Pig, Hive,
resources. Okay.
Spark, Pig, Hive, these are different frameworks.
Frameworks, cool. So Yarn is basically trying to provide resources, abstracting all the resources and providing that in a cluster form, in a distributed resources together, probably. Yeah.
Yeah. So you have a problem statement. You can solve it by writing a Python program or Java program or a SQL query. Okay, as per your own convenience. And basis that you have to execute in on that platform, right? If you are writing a Python program to solve it, you will be running on Python kernel. If you want to solve it using a SQL query, you want to run it on a MySQL server. But here you have the execution or the runtime engine is same. It's a YARN cluster. On top of that, that means even if you are writing a Spark program, that will be translated to YARN understandable instructions. If you are writing a Hive query, which is an ANSI standard SQL query, that will also be translated to YARN understandable instructions. If you are writing a Pig script, that will also be converted to a YARN understandable instructions. Whatever you are writing, whatever your convenience, you are good at Hive queries, you write Hive query to solve the problem, that data ETL problem. You are a Spark developer, you know how to write code in Spark to solve this data problem. So you write the code and Spark instructions getting translated to YARN understandable instructions and they're getting executed on top of YARN. Here the runtime is same, but you have different frameworks. Different companies, different developers have different expertise. So basis their own expertise, they do create different type of projects. But end of the day, they are getting executed on top of your YARN cluster. And AWS EMR is nothing but a managed YARN cluster. You just ask him, give me a 10 node cluster with each node having say 16 core and 64 GB of RAM. It will do all these things for you in the backend and it will give you a cluster in 5 minutes.
So do we also go through Hive and Pig in this course?
Yeah, good question. So as you're discussing, we have three major popular distributed computation framework like Hadoop, Spark, Flink. Hadoop came in the year of 2000, Spark came in the year of 2011, and Flink came in I think 2013. Okay, so Hadoop is kind of a legacy framework now. Legacy framework as in you can imagine. So it has been developed in the year of 2000. So at that time, 2000 means our parent level or our our parent level means when they were using they were into software, they were into programming. So what kind of computers they were using? Mostly Pentium core or even less than that. A computer having only half a core or quarter a core and 256 MB RAM or 100 MB RAM, those kind of computers. So Hadoop has been designed in that way to basically make your code executable on those kind of machines, which is having very less execution capacity. You can imagine Pentium core. Have you seen like any Pentium for last 5 years? No, these are kind of obsolete. Nobody is using that. So Hadoop has been designed in such a way that to leverage the computation capacity of those kind of computers. Every time you apply, you have a data pipeline problem, they have an ETL problem. You have to break that into multiple transformations or multiple functions. Every time you execute a transformation, it will produce the output into the file system. It will write it into the file system, and the subsequent transformation will read it from the file system, apply some transformation, and again write it to file system. In that way, it will keep on going. Okay, in that way, it will keep on going. But wherein in Spark, it's completely different. Okay, Spark came in the year of 2011, and by that time already i3 or i5 processors, i3 processors were in the market. So they designed the architecture in such a way that things will not be always written to the file system. Okay, just like you are creating a variable in Python, say x equal to 10, and in the next line you are saying x equal to x plus 10. So is it like it's first creating a variable x, writing the data into the file system, then it reads the data from the file system 10 and add 10, and it becomes 20, and it again write it back to file system? It doesn't happen in that way, because like IO is always time taking. It's costly operations. So Spark came in the year of 2011, and it tried to utilize the RAM extensively, not persisting the data into the file system. Keep on applying transformations, keep it in the RAM. Subsequent transformations will read from the RAM and again apply transformations like that. In this way, it will keep on going. Okay, so now, so there are two major things. Like Hadoop is a huge ecosystem having Hadoop MapReduce framework, just like we are writing Spark program here. There you can write Hadoop MapReduce program using Java. So there also you can use Hive scripting to write SQL queries to solve your data problem, data transformation problem. Or you can use a scripting, Python-like scripting called Pig Latin. There also you can write the Pig Latin script to solve your data problem, data curation problem. Yeah, there are a whole bunch of tools are there in Hadoop ecosystem. Okay, and as we are discussing, like in comparison to Spark, Hadoop is at least 100 times slower. Okay, so that's why everything is now on Spark only, Spark or Flink. Okay, Spark is a US product, Flink is a German product, and it came from the MIT University, and that Flink came from some German university. So they are completely two different stuffs. And Spark has a huge community, and it's a very active community. Every few months you'll see a new version is getting released. And what if you're stuck somewhere, you search something, you will find open solutions in multiple platforms. It has a huge community. People are using since last 10 years. So Spark is currently everything we are using Spark. Okay, no Hadoop and all. Okay, Hadoop is now a legacy framework because it's at least 100 times slower than Spark. But still, those companies who have developed some project in Hadoop like Hive and all, these are still going on. Okay, so banks and all, they invested a lot of money developing their pipelines and all. They can't just migrate to Spark overnight. Okay, they just yeah.
I do see a lot of energy firms. They still use Hive Pig and Hive Pig, and they talk about Hadoop. So they are all legacy now. So there is no point in actually learning those now, right? Pig or Hive. Rather, is everything in Spark using PySpark.
Exactly. So, but still, Spark just put some effort to still make you comfortable using Hadoop. So, as we discussed in the data frame part, once you read a data and create a two-dimensional table or a data frame out of it, then you can apply the transformations in a object-oriented programming style or SQL style. Okay, that SQL is nothing but the same Hive queries. Okay, because Spark just inherited the same SQL query engine from SQL syntax from Hive, and it just used it as it is without reinventing the wheel. Okay, so if you are good at Spark SQL, that means in the backend you know already Hive. You don't have to put extra effort on that.
So in your course also, I see there's not too much SQL in it. So that is the reason why, because of the part SQL that we deal with. Because SQL, how much knowledge that we need for SQL queries? Because do we actually deal with any query optimization? That the data engineers deal with all the SQL query optimizations and stuff like that?
Yeah, so in data frame examples, all these three things what we discussed here, like data ingestion, curation, provisioning. So all these things we'll be doing it both in programming style as well as SQL style. Okay, so that's the whole idea. So there is no difference. Okay, the same data transformations what you can apply using the programming style, exactly same thing you can do it using SQL also. Okay, we'll discuss all these tuning things also. Okay, how in the backend, in the, as we discussed earlier, like Spark's execution model. So that in that execution model, we'll discuss multiple steps in different sessions, how we do the tuning of the code. Okay, and how do you tune the environment runtime? How do you tune the code? How do you tune the Spark parameters? All these things we'll be discussing.
Yep.
Okay.
But
So
we'll be mainly that Spark SQL is what we'll be using for that.
Yeah.
Not direct SQL, but Spark SQL. Yeah. But that is in an object-oriented way. You're dealing with Spark SQL. Yeah.
Means, and then coming to your big thing, big scripting. Big scripting is kind of, you'll find exactly same as your Python scripting. Very much similar. Okay. The reason they created it because Hadoop was originally on Java program. Okay. And you know, like Java is very expressive. To write a small logic, you have to write 10, 20 lines of code. So there people realize the requirement of some scripting. Just like you can compare Java and Python. The same logic you can write in Java in 20 lines, and in Python you can write in 2 lines or 1 line. Okay, so similar funda there also. So Python, so this big Latin came in to give you a scripting environment to do the transformations. Okay, so like that. So here in data frame, as we are saying, like in the projects, you'll be always using data frames. So we should give enough attention for that. So there's roughly there are 10 sessions, 10, 12 sessions, 10 sessions at least will be there for data frame. There we'll be discussing all these aspects. Like in our traditional data pipeline projects, you first do the data ingestion. You bring the data from the source systems to your lake first. Okay, that is called data ingestion. So then you apply the business logic on that. You do the data denormalizations and all. So that you do it in data curation phase. And then you do the data provisioning. After doing the data curation, you should make it available for the downstream applications or the end users to consume the data. Okay, so all these three aspects we'll be discussing in details, and pretty much all aspects will be covering here. So data engineering, data ingestion means you'll be bringing data from third-party systems to your data lake. What can be the third-party system? It can be a RDBMS like MySQL table, Oracle table, and all. It can be a NoSQL database like Cassandra, Mongo, anything. It can be a cloud storage like Amazon S3 bucket or Azure ADLS Gen 2, or it can be a shared directory like a SFTP folder. It can be a MPP database like Presto or AWS Redshift, Snowflake, and all. It can be anything. So for all these different varieties, we'll be picking up one example, and we'll see. For RDBMS, we'll see like how to read data from MySQL database. For NoSQL database, we'll set up a MongoDB, and we'll see how to read and write data there. For MPP or massively parallel processing database, we'll be setting up our own AWS Redshift database, and we'll be reading and writing data. Like that, all aspects will be trying here.
Yes, Siddharth. So when you talk about streaming data, right? Does that has to be?
We'll come to that. That's the next module. We'll come to that. So in the data frame part, you saw the data ingestion is that we'll be pulling data from all these different systems and write it to the data lake. That we'll be doing in the data ingestion phase. And then the business logic means mostly you are taking the operational data, which is most of the time it's normalized, like 3NF, or like normalized data, multiple tables connected with each other through primary key, foreign key, and all. So we do denormalize them. We do add additional attributes. We do calculate different matrices. All these things we'll be doing it in the data curation phase. That is through two approach, programmatic approach as well as SQL approach. And the last part is provisioning. Once you did the processing and you have a data frame, you have to write it to MongoDB or Redshift and all this.
So what is the most famous approach in the industry? Do they go with the programmatical approach or the SQL approach? I presume programmatical.
It's not about industry and all. It's about the project itself. Okay, so how do you want to basically means there is no industry standard. Okay, industry doesn't restrict it in that way. Rather, say for example, you have a pretty complex business logic to be implemented, and that business logic is very fragile. Like it keeps on changing. Business is not very sure. They every now and then they they come up and they ask like, just change this logic, add a new column or remove this column or modify the backend logic. So there basically we write a SQL query, and that SQL query we can configure it in our application configuration file. And so that like every time a change comes in, without making any code change, we can go to the configuration file, which is pretty much a SQL or JSON kind of file. There you can change it and rerun the application, so it will be incorporated. It's basically your entire business logic can be parameterized if you're going ahead with SQL. And in the other hand, if the business logic is not that complex, we always prefer writing the programming approach, not like in SQL approach, like that.
So the templating option is more predominant in the SQL approach. So that way you can template things and make.
We do use both. We do use both interchangeably.
Also be done in the program. Yeah.
I've seen projects where thousands of lines of SQL queries. I've seen projects where most very less SQL queries. It's everything programmatic. Both the approaches will be seen.
Sure. So it's up to the programmer, or at least if I'm comfortable doing things programmatically, then I can do programmatically.
Yeah.
Right. Okay, cool.
Okay, no other questions from anybody else?
What is data lake that you're referring to?
Data lake, yeah, you can say like data lake is basically the raw repository of the data. Okay, so when you freshly procure data from systems like the transactional or operational systems, you need to keep it somewhere. Okay, you don't directly always, you don't make a live connection to the databases and do the transformations in Spark always, because Spark will try to make hundreds of connections to that database and it will make it slow. So that's why we first read the data from the underlying source systems and write it into a file system. Okay, so if it is on premise, we say like SDFS is our file system. If you are using AWS, then you say you write the data on AWS S3. So S3 is the file system where you create different folders for different data sets and you keep on appending the new data there. Okay, so that's basically what we refer as a data lake. Data lake is basically the raw storage of all these data from the operational systems. And of course, then you read data from the data lake and do some transformations. Means my point is basically you don't always make a connection to the database, fetch the data and do the transformations. Rather, you fetch the data from the databases, write it to your staging layer, which is nothing but your data lake, and then you read data from the lake and do the transformations.
Okay, so data lake can be anything, correct? Means it can be SDFS, it can be
S3, it can be AD less than 2, it can be anything, any distributed file system or cloud storage.
Okay. Yeah. Siddharth, sir, one question.
Yeah. No, sir. Yeah.
Sorry, go.
Yeah.
Okay. Okay, so if we are taking like Hadoop HDFS is a distributed file system and we are referring that to as data lake, then how is the data is getting divided? Like initially it's a cluster. So if you talk HDFS, it's a cluster. So how can we say which data is in which cluster, or how is the distributed happening? Like how is the data getting distributed in all these clusters?
That's everything is abstracted. So that has been already, so the framework what we are using, no, so we are using the yarn cluster. It's basically does that thing. Suppose you are using a Windows machine in your system. You are only interacting, or you are only doing the IO using some file names or folder names. In the backend, how the chunk size or block size it uses, it's completely abstracted from us. Same story there also. Once you ingested data from your traditional, from your data warehouse to your SDFS, say it's 100 TB of data, and you have a cluster of say petabytes of storage. So the moment you uploaded this data from your traditional systems to your SDFS, so you will get a single URL for that entire file. Once the entire file has been uploaded, so you will get a namespace or a URL to access that particular data. You don't have to chase each and every block, how in the backend it manages the data. You'll be, suppose programmatically you want to read the transaction data, you say mention spark context or text file and you provide that URL. So it will basically make sure how to read the data and create an identity out of it. Those things are completely abstracted.
I think, Abhishek, I think I'm sorry. I mean, your question, you were referring to the HDFS has nothing to do with the data lake. Data lake is more about S3 object storage.
No,
That
no,
is a
HDFS
URL.
also is used. HDFS. So in on-premise clusters, sometimes like people also use HDFS as the data lake. Sometimes Hive
Oh,
tables are also used as data lake. Sometimes if you're using
oh,
AWS cloud, we use AWS S3 as the data lake. If you're using Azure Blob Storage or AD Gen2, that's also used as the data lake.
so people actually store in HDFS like object storage itself. Is that also considered as an
That's
object
also
storage
considered as a
or a
lake.
blob storage?
In general, what we
Okay.
say, like when you read the data from the source systems and you keep it as it is with minimum transformations, we call it as a raw layer, or we call it as a lake. Then you again do some further processing at a business entity level and create some specialized tables. Then you call it's a warehouse. Then again you take some data from the warehouse and again do some transformations, and you create a whole bunch of other data sets to solve a particular business problem. Then you call as a data mart, like that. Data mart, the super type is warehouse, the super type is lake. Lake is kind of, as the name, as the hierarchy says, so lake is basically kind of a raw repository. Okay, then further cleansed, further organized layer is warehouse. Then very much business specific, you want to improvise your sales and say pricing information. You take out some data from the, you may not read all this data. You may for pricing and promotion, maybe you need only the sales data, campaigns data, customers data. You only took those three data. You again apply some business logic. You added few more columns and you calculated different matrices and create a separate layer. And that layer is now called as data mart, like that.
Oh, okay. So as the data goes from data lake to data warehouse to data mart, is there a lot of, it's getting more structurized, can I assume?
Exactly. Yeah.
Rather
Correct.
than be
Yeah.
cool.
So
More
Siddharth,
consumable format. Yeah.
yeah, Siddharth, so we don't save the data on local machine.
Local machine is not an option, no, because you can see, even though we procure a very premium machine like say a MacBook Pro having say 2 TB of hard disk and having 16 core and having say 16
But we
GB of RAM.
will do a coding part on a local, na?
Yeah, coding part will be doing local, but there are two things. So one is writing the program and another is executing the program. In traditional software engineering, you can still, means in the traditional software engineering also, you do the development in the local, but you cannot run it in local. Though you can run it, but you have to do the setups. Maybe you have to install the Tomcat server and all, then you can execute. But while working in a project, that doesn't happen. Your server, your what you call application server, say WebSphere and all, it has been installed on a server. You do write a code. Okay, you make some changes, you go for a build, you go for a Jenkins build, and that now your code is built there and put it into the server. Then you execute the application through a command, or you go to the server and you make some clicks and then you execute it. Exactly same story here also. So while working in projects, you do the development in your local computer and you sync up the code with your Git. And if you're using some CI/CD pipeline, you trigger the build process. Then it will build your application and keep it into the clusters master node or Amazon S3 bucket. And from there, you can execute the job. Okay, because in local, executing the job is difficult. Like you can create some mock examples to test it in your local computer, that is fine. For learning purpose, we can do that. But in projects, it's most of the time it's a big no, because you have to bring the data to your local computer and client is reluctant to pass their data from their systems to any other. For example, I'm working for a US bank, and literally I can't even send I can't just copy one line from a text file to that.
Of course.
Yeah. So there is no access, means they will not allow the data to come out of their system. You cannot copy something and bring it to a parent system. That never happens.
Okay, one more question. We have two approaches, a coding approach and a SQL approach. So there is any need to collab them or they are separated all the way?
Don't just divide them. They all go hand in hand.
Okay.
Some transformation in one portion, say you have in your pipeline, there are 10 different data sources you're dealing with. Okay, some data sources are pretty straightforward, and those data you are using to create some basic dimension tables. You may write the code using normal programmatic approach. And at the same time, you are creating some fact table, which is nothing but by joining 10 source tables or 5 dimension tables. So in that case, what happens? Like you have to write, you are writing a SQL query to solve that problem. Okay, we never restrict or we never bifurcate, like in this project we'll be using SQL, in that project we'll be using programmatic approach. It's not like that. Rather, these are different components of your application. Some components you are solving it using SQL approach, some components you are solving it using programmatic approach.
Okay.
Hey Siddharth, I have a question.
Yes, Sanjay.
So we'll be using Redshift as well, right? So
Yeah.
what is the like use case of like difference between MySQL and Redshift? Like when we'll be using Redshift and when we'll be using MySQL?
Yeah, MySQL is an operational database. So in the data area, we say two type of system: OLTP systems and OLAP systems. Online transactional processing means these are your Oracle, MySQL, SQL Server. These are the databases, and these are basically the backend databases for your online application. Say you have a bank in you have account in HDFC or City. Every time you go to your net banking, you do some fund transfer and all this. So it got logged there in the database. Okay, in their OLTP database, maybe Oracle or SQL Server, right? But in the other hand, for the analytical case, OLAP, online analytical processing, these are for your reporting or analytics purpose, right? So for that, we use, so the traditional OLTP systems are designed at a transactional level to support to give you good performance and optimized query and all this at a record level, transactional level. What OLAP is for reporting. So transaction nature is not there. You most of the time you do bulk operations there. So and the previous discussions what we had, no, like lake, warehouse, and mart. So the data marts most of the time, or data marts or warehouses, these are hosted over Redshift. Redshift is a MPP database, massively parallel processing database. It's not just like Oracle and all. These are installed on a single machine. Redshift is installed on multiple machines. Just like Yarn cluster is hosted over multiple computer, Redshift is hosted over multiple computers. So that means naturally you are getting a larger storage, and whenever you are executing some query, these are getting parallelly executed by all these computers. So all these benefits you are getting when you are working on MPP database. Okay, Redshift, Presto, Athena, then in Azure that is Synapse Analytics and all this, right?
Got it. Also, like, will you be teaching data modeling part as well?
In the project part, we'll be discussing about the modeling part. I do cover, like I do discuss about the star schema and all, how do you lay out the tables and all. But yeah, but there are still a lot of things. It's a continuous learning process because it varies like project to project. So I have executed multiple projects and I have seen some modeling, but still I'm giving while appearing for multiple interviews, I do see some completely different type of scenarios come. So there basically we do see like how to basically solve this. So recently I was seeing some question like you have, we'll discuss that in details. Like say we have some invoice data and you have some transaction data, and there is a data synchronous problem. So invoice data didn't come, but the sales data come in. How do you model the data to handle this? Means I don't want to stop the accounting because it's not logged into the invoice table, but it's already available in sales table. So how do I create those fact tables to avoid these scenarios? Even though there is no record available in the invoice, which is a dimension table, but still I have a sales table, sales record. Okay, so we'll discuss that in details. But yeah, modeling part I'll discuss up to some extent, but it's a continuous learning purpose, like a learning process. You have to keep on learning from different projects.
Okay, thanks.
So Siddharth, I have one question here.
Yeah,
like
please.
when we are talking about the data lake and from moving from data lake to data make, do we also do the data cleaning there? And like if data cleaning is there, then how we come to know that like we have an object, raw object, so how we come to know like this object is like necessary for data and others are not necessary?
So
like
most of the time I got your point. So data cleansing is basically happens post data ingestion. So data ingestion is basically you are pulling data from different systems and put it into the data lake. That's the source of truth for your data pipeline project, isn't it? That's your source of truth. You keep it there, and that's you don't do any transformations. You keep it there, and then when it goes for the data curation phase, in the curation phase, first step is data cleansing. Your business most of the time will be having a clear instructions. If you see this kind of records, these attributes missing or that attribute missing, you just fit it with this default values. They'll say if the record is having transaction type this and the audit user column is empty, then fill it with that. If the transaction having transaction amount greater than 1 crore and the transaction type is missing, fill it with this. So all these kind of instructions come from the business most of the time, and we do follow them, and we do the data cleansing, and then we go for the further transformations and write it to warehouse or marts.
Okay.
So we do use different techniques. We do fill the missing values, or sometimes business will say discard those records and keep it into exclusion folder, so that later they will manually verify why this data is having problem and how to rectify or how to make use of that data and all this.
So it's like similar to the machine learning models that we do, like we remove the columns which are not necessary sometimes, so we fill the average of the average values. So it's depending on how the business is going on.
Yeah,
and
so
how
the
they are.
machine learning has completely different different techniques. So you use PCA and all these things, and normal data cleansing activity you do fill mean value or median value like that. So it's not that sophisticated, but business comes up with, say, they know like, yeah, these kind of transactions we intentionally don't populate these fields, but for the reporting purpose we have to manually fill those values. So those kind of input will come.
Okay, sure.
I think machine learning would be way downstream, probably after data pre-processing is done, probably data
Yeah.
coding.
Once you make the data available in the mart, then only the ML part starts. Before that, no ML.
So it's complete downstream.
Yeah, it's the downstream. Once you produce the data in the mart, then the ML team, they can consume the data from there, and they can do further other kind of data imputation and all this.
Sure.
Hey Siddharth, just one more thing. So our company is like trying to move to Cassandra and like DynamoDB for NoSQL. So can you like add that part in your course as well, like one of those two?
Yeah, we can discuss some examples on DynamoDB. Anyway, we have in the ingestion problem, we'll be reading data from MongoDB. We'll see how to read and write data into MongoDB, how to create document. How do we create documents there, like how to store the data as key value pairs. So similar stuff there available in Cassandra also, Cassandra and DynamoDB. So maybe since we are using AWS, so let's do some examples on DynamoDB itself. Okay, but just remind me, okay?
Yeah, sure.
Okay, let me finish the course content, otherwise we'll keep on discussing this. Okay, so Sai, you are not asking anything. Vikas, you asked something. Okay, nothing to hesitate. Okay, even people are asking questions, still it's fine. I think there's a famous proverb, like I don't remember exactly. So means if we feel like asking something, like we feel like we'll be it's not sound like I'm not comfortable for asking this question, like it's just a matter of few minutes. But if you overcome that, if you just ask that questions, like that confusion will not be there, but otherwise it will be there forever, and it will trouble you in the subsequent sessions also. That's why, like, feel free to like ask any questions, like if you feel it's you have some confusion. Okay, so post the data frame part, you saw we will be seeing like how to deploy the applications on EMR, like using step functions and all. We have orchestration tools like AWS step functions, Apache Airflow and all. So we'll be using step functions. Airflow is pretty much same. Okay, means only the language is different. Here you are using JSON like structure, and in Airflow we use Python DAX. Okay, so then so that was the manual approach with AWS Lambda script with AWS step function, and AWS Glue is again another managed Spark framework. Just like Databricks is a managed Spark framework or Spark as a service environment, similarly Glue is also like that. And post that here also we'll see a couple of examples how to do a data ingestion or how to do some data curation, those kind of stuff also we'll be discussing here. And Delta Lake will be seeing like all this data lake, what we discussed, like we store the raw data, how to add some acid nature like atomicity, consistency, isolation, durability. In the RDMS concept, if you have heard about it, acid nature, how to add acid nature to our traditional data lake. So Databricks has a new framework called Delta Lake. Okay, we just came 2 years back. So that also will be seeing all these features of Delta Lake. And then streaming part. Okay, if the data is coming in continuous stream, like every millisecond data is coming to a system, and how to process it instantaneously. Okay, like many companies do solve their fraud detection systems or online marketing. So those kind of things, or advertisement forms, they are the biggest user of streaming applications. So there you will see like how to set up Kafka and how to consume data from that, all these things.
So why does data lake asset properties are important to data lake? I mean, data lake is
It's not like
just
traditionally people were not doing, but given that different type of enterprises have different problems, so then this kind of requirement came into picture. So so most of the time transactional data is always atomic in nature. Once you create it, means you never modify it. But what if my operational system has been designed in such a way that my transaction data also keep on changing? Okay, so there can be many such genuine examples you can see. Say any payment processor. I mean, any payment processor, what they do. So every time you raise a transaction, you go to Amazon checkout page and you make a payment. So that payment goes through multiple steps. First, the authentication happened from the seller side. Then buyer side should receive that. Then the payment processor should acknowledge that. Then the banks from the sender should release the fund. Then gateway should receive that fund. Then gateway should release that fund to the buyer, sorry, to the seller. So it undergoes like 5-10 steps in between. Okay, so when we are creating a data lake which is ingesting data from your operational system at a daily basis, so what will happen? So every day you have to read not only the newly ingested data, also the updated data. Okay, so how will be doing that? You can simply keep the data as it is, then there will be a lot of duplication. I mean, same transaction is available in your lake multiple times. First time it is with status X, second time status Y, third time status Z. So that means your data lake is now in consistent states. But how to make sure, like how to enable my data lake in such a way that it will also incorporate these changes. If I'm pulling data in such a way that it's not just fresh ingestion, it's also updated records, I should update the previous records. In data lake, as you know, you are keeping data from last 5 years, 10 years, 20 years. So updating 10 years old data lake, which is petabyte scale data, it's really tedious and it's time consuming. So that's why like Delta Lake came as it's a sophisticated framework which gives very fast updation on a huge data set. When your data lake is in petabyte scale, it still can update records at a record level or at a batch of record level in a with very fast transaction.
So just to refresh the data lake every now and then and just evolve along with the business is what
yeah, correct.
Yeah, sounds good.
Okay, so those are the things. So post that, we'll be starting with a project. It's an end-to-end project, like we'll be doing hands-on in one of the batch. This project is going on. I will take 6 to 7 sessions for this project. Okay, so we'll discuss all these things, how to pull data from different systems, transaction data from MySQL, loyalty points data from OSFTP, shared directory, campaigns data from Amazon S3 bucket, customers data from MongoDB. We read all this data using Spark connectors, write it to Amazon S3 bucket, which is your lake. Then you read data from the lake, do the data curation and write it to AWS Redshift. Okay, and you, of course, you automate it using AWS Cloud or Scrum tab. That's the scheduler. Step function is the orchestration tool, and Lambda is the layer which submits the jobs to the ongoing ML cluster. Because this entire process will be doing hands-on on this. This is basically nothing but if you heard it end to end from the data plane, we are doing all this ingestion, curation, provisioning. I have intentionally created all these examples like reading data from MySQL and all these things. I've already done it here itself. We'll be pulling those components one by one and we'll be orchestrating them together to create this entire end-to-end pipeline. Okay, that's basically nothing what your project is all about.
So, are we dealing with any DAGs here, like Airflow, tools like Airflow?
So yeah, not just Airflow, there are multiple tools are there. Apache Uji is there. So here we are using AWS step function. Step function is exactly same as your Airflow does.
Okay, cool. Yeah. So we actually started working with step function. So that is almost like Airflow. Cool. So that
So
is almost
Airflow basically what it does, no, it also does the same thing, but you have additional cost. Like you have to set up the Airflow cluster and you have to monitor it, manage it, and all this. And that's a significant cost associated with that. But if you're using step function, I think it's giving 1,000 step function calls free for every month. So kind of for a small organization, you can use it for free without any cost.
Sure. The state function, the state machine is actually a DAG. I think.
Exactly, it's a DAG. There you mentioned like how many components will run in parallel, how which will be running in sequence. All these steps you can specify there.
Sure, sounds good. I think Abhishek and Himang, they both just implemented that, and we're not even aware that we were implementing DAGs. Yeah, sounds great. Thank you.
Okay, so that's all pretty much like what we'll be discussing during this entire course. And yeah, any other questions, anybody? I saw few questions from Tausif and Sai also, Vikas also. But at the same thing, I will say nothing to hesitate. Whatever questions comes to your mind, feel free to ask me. And after a certain time, I'll just add you to our alumni group also. There it's again a very open forum. Anybody ask any question there. Some people even ask their interview questions. So, so that's again another open forum. You'll see many people are answering each other's. So, and we are also getting updated. I do post there like every time a person get off or get a project, I do mention that so that people can know each other, and if another person has an interview schedule, they can ask the questions and all those kind of help we can get there. Any other
So
question?
Siddharth,
Yeah, please.
apart from this AWS, we have Azure also, correct?
Yeah.
As the cloud services. Which one is more in use basically, AWS or Azure?
AWS is the king, but of course, last year Azure just did a very good business. There means Microsoft strategy, they are giving less cost. But AWS is very costly because I was working for a small startup, like we're not more than 200 employees, and only for big data we are getting 20 lakhs bill in INR every month. So, but yeah, Azure is also still picking up. So Google GCP is still, it will take some time. But yeah, nowadays AWS and Azure, these are very popular, equally popular. Yeah.
But Azure is more cost effective, correct? As you said.
Yeah, kind of.
Yeah.
But
And which one is
service flexibility will get, like Azure services are very much flexible because people are using it since last 5-10 years. So, so the experience like you will get, I would say like 2 years before I was having a perspective like comparison between Java and .NET like AWS and Azure, but recently I started using Azure also, but I'm seeing Azure is also giving similar interface, similar flexibility like AWS and all. So they will be the leading cloud providers in the market for sure.
Okay. Means all the services are almost the same as AWS, only in Azure as well.
No, that's what these people are playing trick. So all are not exactly same. Majority, like 70% of things you'll find similar, but a lot of dissimilar stuff will be there. So that's why learning multiple clouds like has significant learning curve. But yeah, means with your experience and you will start understanding more.
But in this curriculum, we will be more focusing on AWS part only.
Yeah, not more, rather only AWS only, because AWS Azure means it's a completely different thing.
Okay.
But yeah, I'm starting a new course on Azure also, but it will take some time for me. But yeah, I have 2 courses like Spark with Scala and AWS and Spark with Python and AWS. So last 6 months, I'm only taking Python because like before that I started Scala and it was almost more than 10-15 batches. So I was bored with that. So right now I'm just running everything on Spark with Python and AWS. Maybe after a few months, I'll be running only on Spark with Scala and Azure. So yeah, means that's how basically I just keep on switching. but I mean, so all are equally in demand. So anyways, you can just search it on LinkedIn itself. Just search big data roles. You see how many openings you are finding on AWS and how many on Azure. So you'll find similar number of openings there. Okay. And don't worry like if I'm learning only AWS, I'm losing few interviews. Not like that. If you give 4 interviews and you crack 1 interview, that's sufficient. We cannot do only 1 job, right? We can't do 3-4 jobs. It's not practical,
Yes,
right?
yes.
Yeah, that's
Correct.
it.
And apart from your this course curriculum, means the areas which you have got, what are the other areas which we need to work on from the since I want to transition my career from testing to this big data?
So I would say if your objective is only transition, focus on this part, practice all these programs like 2 times, 3 times, 5 times. Make sure like you don't look at the code and you self type the code. So when you are going for interviews and programming test is there in everywhere. So if you're typing the program in that way, means chances you will get offer very quickly. So that's and if you have already some experience, I would say you already have some big data background and data engineering background. So apart from this, you can spend some time learning more on streaming, because I'm spending only 2 sessions on streaming. You can spend more time on streaming, more time on NoSQL databases. So those will be some additional steps.
Okay. Okay. Thanks, Siddharth. Yeah.
Start.
Yeah, please.
In the course, would we get any documents or PDF or any kind of videos, or just we get a
videos? Every day end of the session, I do share the video.
The recording or the
recording, correct.
Okay.
So these we can download, correct? Siddharth means.
No, you can't download. These are YouTube videos. First 4-5 sessions on YouTube. Going forward, I'll be using Vimeo only. So these are not downloadable, but you can see it forever. It will never get deleted.
Okay.
Siddharth, one
Yeah,
last question. So,
please.
For streaming, like, will you go through Kafka, then Spark streaming, or like Kinesis?
Correct. We'll set up Kafka one node cluster, and we'll be reading data using structured streaming.
Okay.
And so that you provide the job interview questions as well, means after the completion of the course.
Means I don't note down those questions, but every session I do give at least 2-3 interview questions.
Okay.
Just make a note of that, because in big data is a vast thing. Like, a couple of NITs here in India, they have 2 years masters there in big data. We are finishing it in 60 hours. So every session is full with interview questions. So don't miss anything, because like means intentionally only things what the interviewers ask and how do you work, those things I've included, but there are a lot of things out there, because don't further skim it. You just keep it like this should be the things in your profile.
Okay. And you help in job assistance as well, means providing references and those stuff.
I don't do that, but without the help itself, you see, if you follow me on WhatsApp, or like I'll add you to the alumni group, every month guarantee 5 people are clearing interview every month without my help.
Okay. So
and if you're
we
from
can
US,
reach
I
out.
can help you. If you're there in US, as I'm mentioning, we have 3 forms. They are very active. We can get you offer in maximum 2 weeks.
Okay.
But here in India, you have to just read all this. Okay, you have to practice all this. Okay, many people are clearing interview. It means like some people like getting 2-3 offers also. This yesterday I just posted, this Somen guy, he is having 3 offers. Morgan Stanley 120% hike, L&T 80% hike, and some other startup is also there. And people are getting multiple offers.
So, that how is it in that US? You guys are able to place so many students easily.
I don't know, those vendors will say, but there are tricks are there. I can't just explain it clearly.
I can explain because I'm a well-known DevOps person here. I crack almost